And we've got a lot more solving. So on number 11, we need to isolate the absolute value, so we'll subtract 12.5. This actually ends up equaling 0. But my absolute value is still not isolated. We're going to divide by 4 next. Whoop, sorry. 0. 0 divided by 4 is 0. Alright, so since it equals 0, there's no positive and negative 0. There's only 0. So this one only has one solution. I'm going to add 2.5 over, and x equals 2.5. Number 12, the absolute value is already isolated, so I'm going to go ahead and branch it. Equal to the positive 16 and the negative 16. So we'll add 4 over, so 5x is equal to, when I add 4 over I get 20, divide by 5 and x equals 4. On the right hand side I'm going to add 4 over, that's going to get negative 12, divide by 5 and you get negative 12 over 5. Alright, number 13, the absolute value is not isolated, and so I need to isolate first. I'm going to add 9 over. And then I'm going to get rid of the 3 by dividing by 3. Alright, this one's less than, so it is going to be an and. You can write it either way. You can either branch it, positive, negative, or you could write it all together like this. So 2x minus 6 is less than 6, but it's also greater than the negative 6. The sign's going to flip. So 2x minus 6 is greater than negative 6. We're going to add 6 on both sides. So adding 6 we get 12. Adding 6 we get 0. Divide by 2 and x is less than 6 and greater than 0. On number 14, the absolute value is already isolated. This is a greater than, so it's going to be an or. And so I'm going to go ahead and branch it. X minus 2 is greater than positive 3, or x minus 2 is less than negative 3. And so flip the sign, change the sign as well on that. And so I'm going to add 2 over, x is greater than 5. Add 2 over, and x is less than negative 1. Alright, on number 15, our first step to get the absolute value isolated is we're going to subtract 12. So when I subtract 12, that's going to get negative 6. Then we're going to divide by 3. And here's another special case, because the absolute value cannot be negative. It has to be positive. So on this one it says a positive absolute value. The positive number is less than or equal to a negative number. That's not possible, because positive numbers are always greater than a negative, not less than, so that's a no solution. On this one we're going to divide by negative 4, so we get absolute value of x plus 2. It's going to flip the inequality, because anytime you multiply or divide by negative, it flips the inequality, and we divided by negative 4, so it's negative 4. Again, we have a negative, so we're done, but the absolute value is greater than or equal to a negative. That's true for everything. Absolute value is always, positive is always greater than a negative. So as a positive is always greater than or equal to a negative. And so this is all real numbers. Alright, on number 17, we've got to isolate the absolute value, so we're going to subtract 5 first. When I subtract 5, I'm going to get 10. Divide by 5 next. And so that's going to be 2. This is greater than, so this is going to be an or statement. So I'm going to branch it. 2x minus 4 is greater than or equal to the positive 2, or 2x minus 4 is less than or equal to the negative 2. And so we're going to add 4 first. 2x is greater than or equal to 6. Divide by 2, x is greater than or equal to 3. Add 4, 2x is less than or equal to 2. Divide by 2, x is less than or equal to 1. Those are my two possibilities. Alright, number 18. Our first step is we're going to add 4 over. So we get 2/5. 5x plus 7 is equal to 56. Alright, I do not have a calculator on me, so we're going to test my mental math. We're going to multiply by the reciprocal, so we're going to multiply by 5 over 2. Alright, so 56 divided by 2 is 28, times 5 I believe is 140. Alright, I think that's right. And so now it's time to branch it. So 5x plus 7 is equal to positive 140, and 5x plus 7 is equal to negative 140. We're going to subtract 7 and divide by 5. We're going to subtract 7 and divide by 5. And if you're ever unsure of your answers, or maybe you have answer choice, you can always plug these back into the original and see if it works out to be true. Alright, and last one, number 19. It says, for this equation, are these the solutions? There's two ways you can do this. I'll show both ways. One way, we could solve this one and see if it matches this. And so I'll go ahead and show that way. I'm going to add one over, because we got to isolate that absolute value, divide by 2, and now we branch it. X plus 7 is equal to 5, x plus 7 is equal to negative 5, subtract 7, x equals negative 2, that checks. Subtract 7, x equals negative 12, that doesn't check, so my answer is no. Those are not the solutions. The other way you could do it is you could just plug these in and see, do they work? And so my first one, I would put 2, negative 2 plus 7 minus 1, and see, does it equal 9? Negative 2 plus 7, that's 5, minus 1 equals 9. Again, we're wondering. 2 times, the absolute value of 5 is 5, 2 times 5 is 10, minus 1 is 9, that checks. So negative 2 works, but now trying the 2, positive 2 plus 7, minus 1 equals 9. 2 plus 7 is 9. Absolute value of 9 is 9. 2 times 9 is 18, minus 1. 18 minus 1 is 17, not 9, so the answer is no. So either way you do it, you get the same answer. It's good either way. But good luck on the test. Hope everybody does well. Thank you.